just got finished putting some ink down on the skateboard blank that I pulled out of the press the other day, and I wanted to show you guys how to do some light fiberglassing, some light composite work that's really easy. You can do it at home without any specialized equipment. So I wanted to run you through this. This is just going to be a manual laying of glass onto the board. When we talk composites in the context of boards, what we're talking about is taking a fibrous material and wetting it out with a resin that is going to cure, lock that fibrous material in place and adhere it very strongly to the core or the board in question. And then we get the additional benefits that come from that mix of the fiber and the resin. The materials that people do this with are fiberglass, obviously, but then also carbon fiber, Kevlar. You can get out there and do some natural materials like a linen or a flax. There's really a ton of possibilities, and the different materials that you use will give you different qualities. The reasons you would want to do this would be to add some stiffness to the board, add some springiness, some extra pop. You could add some durability if you wanted to add some Kevlar to your nose and tail. It wouldn't wear down as fast, things like that. Today I'm going to be doing just a really light fiberglass on the bottom side of this pool deck. It's to give it a little bit of extra stiffness, a little bit of extra pop, a little bit of extra durability, although I'm less concerned about that. The materials that we're going to use are, we start with a two-part resin. This is a boat building resin, but the West Systems is pretty good to go with in general. They make very good stuff. You need all the proper equipment for that, so I've got gloves, I've got a mixing cup, I've got a respirator over there. You need your glass. I'm using a biaxial 0.90 6-ounce glass, and what all those things mean is biaxial means you've got fibers going in two directions, so you've got fibers going this way, and woven in you've got fibers going this way. 0.90 means that the direction of those fibers are 0 degrees and 90 degrees to them, so sometimes you'll see a 45-45 and the weave will be kind of on the bias. Those types of weaves give you different properties. Basically, the qualities that you want to get out of the glass happen in the direction of the fibers. So, if you were to run fibers this way, you would get stiffness in this direction. If you were to run them this way, you'd get stiffness in this direction. You'd reinforce your concave a little bit. So that's what's going to happen when I add this glass. But if this were a 45-45, the fibers would be going kind of on the bias to the direction of the board. And what that does is add torsional stiffness. Makes it so the board twists less. And then there are triaxial glasses, and there are also unidirectional glasses, or cloths in general. It's not just glass. The same thing goes for fiber and Kevlar and everything else. The next thing you're going to need is a sheet of clear plastic that's clean. You take the time to wipe it down, make sure that there aren't any dust or particles or anything on it, and then a squeegee. This is one that I 3D printed. The print didn't come out so good, but it works, so it's going to be fine for us today. You want to cover your workspace in some kind of plastic and make sure that you're wearing clothes that you don't mind permanently damaging, because resin doesn't stain, it gets into your clothes and cures, and it's impossible to get out. So that does it for materials. You can get most of this stuff at a normal home store. You might not be able to get this specific resin, but you can get two-part resins. If you're going to do that, don't go for the ones that come in the squeeze tubes that are like 5-minute or like easy epoxies. Get something that has a... You can usually tell by the cure time and also the kind of container you come in, because you want it to be liquid. Most of the time when you get these two-part resins, like these types of things, just kind of home resins, they're very viscous. It's also, this is a pretty small volume, but you're going to want something that's a little bit more liquid before it sets, because what we're going to do is wet out the cloth. And I'll get into what that means in a minute. When you mix and cure epoxy resin, it off-gases. It's not a glue that dries, it's a chemical reaction, that's why it comes in two parts. And to get into the details a little bit about how composites work, resins aren't actually sticky, they're not a glue. The two parts are a resin and a hardener, and when you mix the two together, a chemical reaction starts, and when it's done, it becomes a solid instead of a liquid. You put resin on a material or soak a material with resin, it gets down into all the microscopic nooks and crannies in the material, and then hardens, locking it into place like a puzzle piece. So we're going to rely on that quality of resin to make sure that our board, which is a nice porous material, it's wood, this one's bamboo, and our fiberglass cloth, which has got all these little gaps in between the individual fibers in the cloth, lock it together to make one solid composite unit. And we get the shared benefits of all the materials working in sync. But because it's a chemical reaction, it does a thing called off-gassing. As the reaction happens, it releases some vaporous chemicals into the air. So when you're doing fiberglass work, you want to wear a respirator. Those chemicals are bad for you. You can develop allergies to them, and they're mildly carcinogenic. It's the same reason you want to wear gloves. You don't want to touch this stuff. You don't want to get it on your hands. It's not good for your skin, and again, you can develop reactions, or long-term exposure, again, is carcinogenic. So make sure you're doing all the proper things safety-wise. It's worth the extra couple bucks. So what I'm going to do, since I have to be wearing a respirator while I'm doing all the glass work, is I'm going to just tell you about the process and we'll show you how it goes as I'm discussing it. So like I said earlier, what we're doing is a manual glass, which means we're going to mix the resin, wet out the glass, which means since it's a cloth, what we're doing is soaking the cloth in the resin. And then we're going to wet out the board, so make sure that all of the pores and everything in the wood get filled up. And then we're going to put the resin on the glass and manually squeeze as much of the resin out as possible, make sure there are no air bubbles, the kinds of things that a press or a vacuum bag would be doing. We can do it by hand. That's what the plastic is for. So the first step is going to be to get our workspace set up. So we're going to get our resins in place. We're going to make sure that we've got our safety equipment on, get all of our mixing and measuring hardware out. I've got these nice squeeze nozzles that pre-measure everything so I don't have to worry about the ratios of the resin. The next thing we're going to do is make sure that our clean piece of clear plastic is pretty close to our board, but also in a place where we can spread the fiberglass out on it. Some of the fiberglass, especially if it's coming in a pack like it would from a home goods store, it comes folded and sometimes the fibers will get misaligned. So you want to try to get an area that's as much as possible has all the fibers running in the same direction. There aren't any little bubbles or anything like that. So you can take a second to kind of realign things if they've started unweaving a bit. The reason you want the plastic to be clean is because anything that is on the plastic when you pour the resin on it will get trapped in that resin, and there's no way to get it out once it's in there. Okay, this is looking all right. This isn't going to be the best layup. I absolutely prefer getting my glass cloth off of a roll just because you don't have to worry about fiber alignment so much, but I don't have a lightweight one. This is just a really light touch. The next step is going to be to measure out your hardener and your resin and mix them together thoroughly. The resin that I'm using requires you to mix for about a minute, and it's got a really long work time, so that's going to be to our advantage. Once the resin's mixed thoroughly, you're going to pour enough resin into the fiberglass to soak it completely. And I would recommend, if you haven't done this kind of thing before, starting with fiberglass as a material because it's transparent. And as it gets wet, as it's fully soaked, it goes almost completely clear. It's a really good indicator to know that you're using enough resin with your glass. And later on, when we transfer the glass to the board, it's a really good way to tell whether or not there are bubbles. You want to make sure that the glass is completely soaked or wetted out. So after you've poured in the resin, you can use your squeegee to move some of the resin around, get rid of any air bubbles, any gaps, anything like that. Once your glass is wet, you can do the same thing to the deck. You want to make sure that it's covered in resin. Most of this will probably get squeezed out, but adding resin to the glass and to the deck ensures that you're going to have a really good bond between the two. Once both the board and the glass have been wetted out, you can take the clear sheet of plastic that the glass is on, flip it over, put it on top of the board. Be very careful to make sure that your fibers are all going in the directions you want them to. Make sure that the part of the glass that you want on the board is where it needs to be. Then you can use your hands or a squeegee and push down on the plastic, making sure that all of the air bubbles are out, making sure that you don't have any excess resin, making sure that the board and the glass are in contact with each other through the resin, and making sure that you have a nice smooth surface on the side that's facing you, because that's going to be your surface finish when you pull the plastic off the board. And actually that's the reason we're using plastic. Resin doesn't adhere to plastics, so having it on the fiberglass and having it on your workspace makes cleanup a little easier. And the reason we want to use a clear plastic on the glass is that same way that when you were wetting out the glass you could look for bubbles or places that hadn't got enough resin yet, you can see through clear plastic to make sure that the glass is laid down and making good contact with the board. After that, you wait for the resin to cure. There's a stage in the chemical reaction with epoxy resins called green, when the epoxy is hard but still, you can still kind of dent it. Some of the older resins actually change color, which is why it's called being green. I've heard that that's the best time to pull the plastic off of the layup, but you can also just let it completely cure and the plastic will still come off. So whichever you feel more comfortable with is probably the best way to go. I think for my purposes today, I'm going to let this get a full cure. We'll come back after that's done and I'll show you the results. Excellent! Our deck has gone from being a wooden deck to being a composite. We've got a fiberglass layer on the bottom that's going to add extra rigidity, extra pop in this case, and it all went really smoothly. It was really easy to get the plastic off. If you were doing this on a pre-existing deck, the next step would be to take a knife and clean off all the flashing, which is all the extra material that has come over the sides. And then just resand and re-round your rails so that they're nice and smooth, because the fiberglass and resin can be actually really sharp and abrasive and will cut you to hell. Since this is still a blank, what we need to do next is make a template. Trace the template onto the board. Rough cut it. Sand it to shape. Shape the rails. And apply a finish. And after all the cleanup's done, what you're left with is a fiberglass reinforced skateboard. It'll be a little bit stronger, a little bit stiffer, a little bit more pop to it, springier, and it's really easy to do. You can do it with materials from your local home goods store, so give it a shot. Let me know what you think, and I'll see you soon. Cool. I think that's all I really needed to say right there. That's great.